here we go. To remind ourselves how to factor today, remember our little process was first times first had to be the first thing. What times what is x squared? X times x is x squared. And last times last had to be positive 9. What times what was positive 9? 3 and 3 or 9 and 1? Which one are we going to use? 3 and 3. Yeah, it's a perfect square. Positive 3 and positive 3 is how we get that positive 6. And is there another way I could write this? Like, this seems kind of repetitive, doesn't it? Quantity squared. Very good. So x plus 3 quantity squared. This is called a binomial square. Because binomial, it's got 2 terms, 1, 2, and it's being squared. So we call it a binomial square. Today, this is what we're doing. We're writing trinomials as binomial squares. All right, trinomial, 3 terms, 1, 2, 3. All right, 2 terms, binomial, 1, 2. All right, so down here, same thing. We want to factor. What times what is x squared? X times x. And last times last has to give us positive 16. What times what gives us positive 16? Negative 4 times negative 4. So we want x minus 4 and x minus 4. That's how we get that minus 8 when we check the rainbow. And then how could I write it as a binomial square? X minus 4 quantity squared. That's what we're looking for today. So instead of writing it out 2 times, our shortcut is to use a power of 2. All right, which means repeat me twice. Okay, very, very good. Hopefully that's perfectly understandable. I want to show you today, completing this square is kind of a weird process. And a lot of students just memorize the process, but really don't have any understanding as to why it's called completing the square. So I want to introduce you to algebra tiles. How many of you have used algebra tiles before? That'd be a big fat none. All right. This and these are algebra tiles. Oh, have you seen those before? Yeah, maybe, maybe not. Okay. So don't confuse them with base 10 blocks, which are the unit cubes, the centimeter cubes, and then 10 rods where they're stacked at 10. This is slightly different than that, but on the same idea, same understanding. So first of all, what are these? What does this represent? Yeah, this is a 1. When if I have, this would be 2, and this would be 4, and this would be 7. Yeah, so we can use these tiles. These are just 1s. Okay? All right, good, good, good. So those are 1s. This represents x. So this represents 1x. What's that? 2 x's. Got that? What's that? 3 x's. That's 3x. 3 x's. And so this would be 5 x's. You see that? Isn't that interesting? So then I can represent polynomials as well. So what's this represent? 3 x's. 3 x's plus 3. Or this is maybe 4 x's plus 3. Or I could change it, and this is 3x plus 5. Yeah, 3x plus 5, right? So it turns out that all these polynomials, this would be 5x plus 7, sure. So all of these polynomials that we've been writing about actually have visual representations as well. And I particularly like that. And for all you women in the room, that's really kind of interesting because it should be for men too, you're visual creatures. All right? All right. Yeah, you are all creatures. All right, so So all of these things have this visual representation as well. And that's really, really important thing. So here's what we're doing today. So this is, 5x's plus 7. That's fantastic. So back to the x. Now that I know that this is 1x, what I need to do is be able to multiply them as well. And so what I'm going to do, just like in elementary school, when you multiplied, create this little multiplication chart. Okay, if I wanted to multiply x times x, just like we multiply 5 times 5, what was 5 times 5? 25, right? And you'd fill in, there'd be 25 little boxes. Okay, so what happens when we multiply x times x? What do you get?
X squared.
Oh. What do you think this is? X squared. Yeah, it's x squared. And lo and behold, it's a square. Holy crap. I find that completely amazing. That x squared actually is a square. Okay. Yeah. Pretty amazing. Okay. So this represents 1x squared. What's this? 2x squared. And what's that? 3x squared, right? Okay. All right. So now, today we are completing this square. And so today you're going to see expressions like x squared plus 6x. And I can represent that using my algebra tiles. There's 1x squared. And here are my 6 x's. And so today, what we have to do is we have to take this little information that we're given, this 1x squared plus 6 x's, and I literally have to complete the square. What that means is I have to take what I've been given and rearrange it to form a square. So right now I've formed a big long rectangle, so that's no good. So I need to do a little rearranging here. So I need to take these 6 x's and I sort of need to do, what do you think I need to do? Split them? I need to take some, where can I put them? I'm going to turn them and push them over here. Oh, that's interesting, right? So all right, so I have the formation of a square here, but there's this missing piece, right? This is what it means to complete the square. All right, it says, hey, what needs to go in this little space to complete the square? What goes in there? The 9 little ones. That's exactly right. 9 little ones. That's exactly right. So we can fill in and literally complete the square. Do you see how I'm literally completing the square? All right. That's why it's called completing the square, because we had to figure out what we needed. This was what we needed, these 9 little ones. Notice the emphasis there. It's not 9 little ones, but 9 little ones. Okay, so now how do we get those 9 little ones? How did we get 9? It came from rearranging these 6 things, right? What did I have to do with the 6? I didn't keep them together. What did I do with the 6? You took half of them. I split them in half, right? So we took our 6, and I took half of those 6 things. And then, well, half of 6 gives me 3. What do I need to do with the 3 to create 9? Square it, yeah. So this, ladies and gentlemen, is how we get the 9. Half of 6 quantity squared. That's what we're doing today, folks. The whole thing. Half of the 6 squared. Here we go. That's what we're doing. All right. Is that one? Find the value of C that completes the perfect square trinomial. Ladies and gentlemen, today on your worksheet, don't follow the worksheet directions, follow my directions. All right? So you're doing what we're doing in class. All right? What you're doing in notes. Find the value of C that completes the perfect square trinomial. Then write the expression as the square of a binomial. Lots of vocabulary words in there. I hope that you use those words. Find the value of C that completes the perfect square trinomial. Then write as the square of a binomial. Okay, here we go. So I have x squared minus 10x plus c. Thank you. And so I want to figure out the value of c. And to do that, I have that little formula. C equals, what did we have to do? Half of, I'm going to say the number b, quantity squared. This is how we calculate c. The reason I said b is because our standard way to write a quadratic expression is ax squared plus bx plus c. So you can see right here that b lines up with the number in front of the x. Okay, so to figure out this constant, c, constant term, we have half of what? What's our b value? 10 or negative 10? Negative 10. Half of negative 10 quantity squared is what we need to do. What's half of negative 10? Negative 5. Very good. And I need to square that. What is negative 5 quantity squared? Positive 25. Why is it positive 25? They're both negative. Yeah, negative 5 times negative 5 is always going to give us a positive 25. This value of c should always be positive. Okay? So what I have then is I can rewrite my trinomial x squared minus 10x plus 25. This is our perfect square trinomial. And from here, I am going to factor, just like we did in the do now. So I'm going to double bubble. What times what is x squared? X times x. And what times what is positive 25? Negative 5 times negative 5. Negative 5 times negative 5. And I can write that as a binomial square, which is what we're looking for. X minus 5 quantity squared. These are the two parts we're looking for today. The value of c and the binomial square. Okay. So letter B, x squared plus 16x plus c. How do we figure out that c value? Take half of 16 and square it. Half of 16 quantity squared. What is half of 16? Oh, come on. What's half of 16? 8. Oh, there it is. Woo, baby. Sleepy, sleepy. All right. And what is 8 squared? 64. Very good. There's our c value. So what is my perfect square trinomial? Plus 64. Good. So I'm just plugging that c value back in for c. X squared plus 16x plus 64. And now I can factor that. How does it factor? X times x is x squared. What times what is 64? 8 times 8. Yeah, this number right here. Positive 8 times positive 8. How can I write that shorthand? quantity squared. X plus 8 quantity squared. I'm showing lots of work. Can you do it faster? You can. Yeah, speak for yourself, right? Okay. There are definitely shortcuts you could take. All right. Okay. Letter C, x squared minus 9x plus c. How do we figure out that c value? 1/2 of 9 or negative 9? Negative 9. Always, always include the sign. Quantity squared. So I might want to bust out my calculator. This one is an odd number, so it's not going to divide evenly. So you're welcome to use a calculator, but this is why I write it as 1/2 times 9. That's 9 over 1. How do you multiply fractions? Straight across, which means half of negative 9 is negative 9 over 2. All right? Straight across. 1 times negative 9 is negative 9. 2 times 1 is 2. Multiply straight across. It's much faster than your calculator. Okay? Now, how do you square that? What is negative 9/2 quantity squared? What does it mean to be squared? Multiplied by itself. So what's negative 9/2 times negative 9/2? 81 over 4. Yes. Square the top, square the bottom. 9 squared is 81. 2 squared is 4. All right. 9/2 times 9/2. 81 over 4. Okay. Could you use your calculator? Yes, you can. Let me show you what happens when you use your calculator. You have 1/2 of negative 9. So 1/2 times negative 9. Can you see that? Okay. You get negative 4.5. And then I want to square that answer. So answer squared. That gives me 20.25. I'll tell you right now that 20.25 is terrible to try to factor. The fraction is way easier. So how can you get around those decimals on your calculator? Math bracket, okay? Don't forget that you have math frac on your calculator. So math, convert to a fraction, 81/4. On a Casio, you have the fraction decimal button. Learn to use those buttons, fraction to decimal, all right? So put in a decimal, and then it'll convert it to a fraction for you. All right, so my trinomial is going to be x squared minus 9x plus 81/4. I want to double bubble that. X times x is x squared. What times what is 81/4? Negative 9 over 2. Yeah, hey, guess what? It's always right here. Always whatever is squared. Nice. Negative 9/2 and negative 9/2, which I can write as x minus 9/2 quantity squared. Notice it's always. So like always. Like
so you just
always.
put whatever's right there.
Yeah, like always. Kind of nice, right? All right. Last one. Again, with the crazy fractions, that is really not a problem. How do we figure out this constant value? Half of 10/3. Half of 10/3 quantity squared. So what do you do with the half times 10/3? Multiply across. What does that give you? 10 over 6 quantity squared. Can you reduce that? Yeah, absolutely reduce. All right, so what is 10 over 6? How does it reduce? 5 over 3. Good. So we divide by 2, top and bottom. So 5 over 3. All right, what is 5/3 squared? 25 over 9. Very good. That's our value of C. 5/3 times 5/3, 25 over 9. So I have my trinomial x squared plus 10/3 x plus 25/9. How's that going to double bubble? X times x is x squared. What times what is 25/9? 5/3 times 5/3. Yeah. 25 is 5 times 5. 9 is 3 times 3. So 5 over 3. 5/3 and 5/3. X plus 5/3 quantity squared is what we're looking for. Again, it is just the 5/3. It's easy or hard? So it's easy, yeah? Okay. Again, ladies and gentlemen, the things that I've boxed are the answers we're looking for today.